Bonsuelo, everybody. Back for more torture. Okay, today what we're going to do is we're going to go through the more precise methods of solving a system of equations. First, we're going to go through substitution, then we're going to go through addition, or sometimes called elimination. Elimination or addition, same thing. Here's the step-by-step what to do, and so I'll leave you to read that, but let's go through the example that I went through by graphing. So this is the exact same example. We already did it by graphing. Remember, we came up with something like 0.5 comma 0.3 or 1/2 comma 1/3, something like that. You might have come up with like 1/2 comma 1/2. It's not going to be real precise. But anyway, let's solve this by substitution. What you're going to do is pick one variable in one of the equations, solve for that variable, and then put it in the other equation. It has to be in the other equation. So usually, not always, but usually, there's going to be one variable that's easiest to solve for. So if you take a look at this problem, solve it by substitution. And by the way, if I tell you to do it a certain way, you have to do it that way. If I don't specify what method, you can do whatever method you want other than graphing. I don't want you to do it by graphing unless I tell you to. And I'll just tell you, as the problems become more complicated, I find elimination much easier. But if I tell you to do it one way, make sure you do it that way. Okay, so let's take a look here. Just take a quick look at it. What do you think would be the easiest variable to get by itself right now? And what I would pick is the y in the second equation, okay? So what I'm going to do is move the y over to the right-hand side and then move the 1 over to the left, okay? Now I'm going to take that and put it, and it has to be in the other equation. So we have 2x plus 5, and in place of that y, I'm going to put 4x minus 1. And then you just have an equation in one variable and solve it. So it's 2x plus 20x minus 5 equals 3. So 22x equals 8, and x equals 4/11. Now, at this point, you can do what you want. If you want to, probably the easiest thing to do is substitute the x back into one of the equations. I don't know, I would probably pick maybe the second equation, but it's about equal here. So I'm going to substitute that value for x into the second equation. So we have 4, and in place of x, I'm going to put 4/11 minus y equals 1. At this point, we have an equation with fractions. So let's multiply both sides by 11. So if I multiply this side by 11, you get 4 times 4, or you can just put 16, minus 11y equals 11, right? Because if you multiply the first term by 11, you don't multiply both of those factors. You only multiply one of them. I think it's pretty obvious to be the 4/11 because you're trying to get rid of fractions. Okay, so let's, I'm going to move the negative 11y to the other side. I always like my variable to be positive. And then we're going to take the 11 and move it over to the left-hand side. So we have 16 minus 11 is 5. So y equals 5/11. Okay, so what's your answer? The point, 4/11, comma 5/11. Now, that's exact. What did I get when I did this by graphing the last time? I think I got 1/2 comma 1/3. Is that close? Yeah, that's pretty close. I mean, the 1/2 comma 1/3 to get it by graphing, because graphing's an exact way to do it. But if you're doing it by substitution or addition, you need to get it exactly. Okay? So that's what you'd get. Now, to do this by elimination, okay? Now, the idea here for elimination, you can read through how to do it, but the idea is, think of this. Think of it as getting rid of a variable. Don't think of it as, how do I find the variable? Yeah, okay, that's what you're doing. But what you should think of it as is, what variable can I get rid of? So here, what do you think is the easiest variable to get rid of if we add the two equations together? And how you do this is you get one variable to have its exact opposite, one variable in one equation to have its exact opposite in the other equation. Here, does it really matter? In other words, because we choose to get rid of the x's? Yeah, the x's are pretty easy to get rid of. Could we choose to get rid of the y's? Yeah, the y's are pretty easy to get rid of. So take your pick. I'm going to get rid of the y's, but quite frankly, it really doesn't matter. Okay, what I'm going to do is I'm going to leave the first equation alone. And the second equation, I'm going to multiply by 5. Because if I multiply the second equation by 5, notice the first equation and the second equation have the exact opposites as far as the y goes. And then what I'm going to do is add them together. The y's don't go away until you add them together. So if I add the equations together, we'll get 22x equals 8 and x equals 4/11. Now, when I say you have to do this by substitution or by elimination, that's basically the first variable you find. So like in this case, I found x first on both of them. How you find the next one, the next variable is up to you. So like some people will take x equals 4/11 and they'll substitute it back in, like I did in the first one. Okay, normally that's what I do, except I don't want to deal with fractions if I can avoid it. When I did it by substitution, I couldn't really avoid dealing with fractions. So I want to avoid dealing with fractions here. So you can substitute the 4/11 in like I did when we did it by substitution. But what I'm going to do is I'm going to do it by addition a second time. Only the first time I got rid of the y's, this time I'm going to get rid of the x's. So what can I get the x's to be? One of them, negative 4x, and the other one 4x. So I can leave the second equation alone, and I'll multiply the first equation by negative 2. So we get negative 4x minus 10y equals negative 6. That's the first equation multiplied by 2, and I'm going to leave the second equation alone. So we'd end up with negative 11y equals negative 5, and y equals 5/11. So what point makes both of these statements true? 4/11, comma 5/11. In other words, you're going to get the same answer whether you do it by substitution or elimination. I just want you to know both of them. Why is that? Because I think as the problems get harder, elimination is easier. That's why I want you to know that. But what about substitution? There are some problems you can't do by elimination. So you have to know substitution, okay? And of course, you should also know graphing, but you're not going to do that unless I ask you to. Okay, at the bottom of this is just kind of a summary of everything that can happen here. Remember I said sometimes something weird's going to happen. Okay, so first of all, what happens most of the time? The graphs intersect. If we look over here on the left side, the graphs intersect. But what else could happen? Well, the graphs could be parallel and then not cross at all. And the graphs could overlap. They could be the same line. Well, how many answers do you get? Well, if they cross in one point, you get one answer. What does the answer look like? An XY point. That's what happened up here, right? They crossed in one point. And it's got a classification, which I'm not that interested in. Alex may ask it of you, in which case answer it, but I'm never going to ask it. It's just not that important. It's called consistent and independent. Okay, what's the second possibility? They're parallel, in which case, where do they cross? They don't. So they're how many number of answers are there? There are none. And what do you write for the answer? No solution. Nothing makes both of those statements true. Okay? So again, when something weird happens, think, okay, could it be this? And that's called an inconsistent system. Now, if the graphs are the same line, you have an infinite number of answers, but infinite is not the answer, okay? a number of answers. What does the answer look like? You just write the equation of the line. And we'll get to something like that in a little bit. And that's called consistent and dependent. So again, these are all the possibilities. I just wanted to point that out. On the next one, next file, we'll go through, next video, we'll go through some more examples. So I've gone through the same example, but I did it on the first video by graphing it, on this video by substitution elimination. Well, here, or next, we're going to go through several different examples and see what can happen. Bonsuelo, everybody.